So one of the things which Databricks automatic machine learning does is it generates what we call data exploration notebook. And this is here. So if you click data exploration notebook, you'll see that this is the notebook that if you are a data scientist, you'd pretty much do this. We call it exploratory data analysis or data exploration for short. This is pretty much to explore your data set. Whenever you got a new data set, you wanted to do machine learning, you wanted to know how many features we've got, what is the correlation between the features or the columns and the target columns, whether they're nulls, they're categorical features, numerical features. If there is nulls, what kind of imputation do I need to think about? You know, what is the pipeline you need to build? This is all we call like data exploration. It's like a preparation, like warming up before you actually run the machine learning itself. And Databricks pretty much does this, but with the way Databricks do it is kind of like unique in a sense that we give you the code itself. There are a lot of machine learning or automatic machine learning algorithms in the market where it operates in what we call a black box kind of thing. Like, okay, you got the data. Okay, give me the data for classification. I'll give you like an API that you call. I will give you the response. You don't know what's going behind the scene. Databricks doesn't do that. Databricks automatic machine learning is a glass box in a sense that you got the code. You can actually modify the code. Like you can go to the code here, you can write some imports, do some logging, do whatever you want. You can actually run the code again. It's like a typical notebook where you can modify, read, add some logging and stuff like that. And this is the code here. You can look at it. There is profiling results, and then you got the actual profiling. It uses pandas profilers. It's pretty much standard, but it has a lot of information. Like we have 12 variables. There is 7,400 rows or observations. There is 531 missing cells. A lot of information. And you can start exploring the data. So passenger IDs, how many zeros, how many missing, percentage of missing, P class. Very good analysis about every single every single class or every single feature of your data set. As a data scientist, you find it very, very useful. You could do it yourself. You can go download the pandas profiler and write the code. You can do that, but Databricks make it easy for you. With just one few clicks, you can see all of this in one place. And this is the correlations between the columns, and pretty much works very good. So if you wanted to know what you want to do, and it gives you different analysis, Pearson, automatic, a lot of interesting stuff. This is what we call the exploratory data analysis, and it's in your workspace here. You will see that Databricks created the automatic machine learning notebook inside your workspace here. Yours Databricks automatic machine learning. If you click there, right, you'll see that the Titanic survived and Titanic survived silver. You could see a lot of the data set. This is the data exploration notebook. There is a failed notebook. There is trials. If you click on the trials, you'll see everything that already generated for you, right? Also, one thing that Databricks generates is called view the notebook for the best model. Ideally, it will be the one in the top here, which we call it, I don't know, Mercurial, Schwat. Okay, so view notebook. So click here and you view the notebook. So you look at the notebooks here. It has everything that Databricks has written in a code in order for you to run this machine learning experiment. So let's see what it does. So it has loaded the data here, loading the data using pandas, read the data from the files, done some selected supported columns. So we get the columns that we can, work on. That's pretty much all of them. Preprocessor Boolean values. This is how to handle Boolean values. So, like 0 1s kind of thing. So we're gonna do a simple Boolean transformer. Numerical columns. If you're gonna do imputation, I think I said everything gonna be the same, automatic. So we're gonna do some imputation, like how we could fill the null values. You could fill it with a median value or a most common value. Categorical features. Low cardinality. Like it gives you, if you are a data scientist, this is what exactly you would do. Databricks like give it to you already, so you don't even need to write code. I've seen a lot of customers where if they have a regression forecasting classification problem, the first thing they do, start with AutoML. Get the best model and evolve it, change it, add logging, add more interesting data, machine learning algorithms, change the test, train test validation split, do all kind of things, maybe hyper tune the parameter of the model. So you got everything here. You just need to either run it as it is, or change something for your liking and do everything that you wanted to do in order to make it work. So this is I think this is the define the objective function. I think we said the F1 score would be the function that we would use. Hyperparameter search space, how you could change the hyperparameters, what kind of hyperparameters we would use. I think this algorithm is a logistic regression algorithm. So logistic regression has a C value and penalty, regulation parameter L2, random state, how you would run these trials, pretty much all the things that you would do here. You do feature importance as well using SHAP, and very, very good. If you are a data scientist, you could do a good job. This is like a very good job for machine learning. It does everything that you would do for this kind of problem, and defining everything and confusion metrics, and you can see the area under the curve. It's very, very good analysis of the machine learning model, and Databricks has run it all for you. So we did run this algorithm, and this is how you see here in the right side. If you click here, there is experiments, right? You will see Databricks has already run this algorithm multiple different times with different parameters. You can see the runs in here when you click on experiments. So if you click in the classifier, you'll see all different parameters that has been tried and tested. And if you click on test accuracy, test sample count, all the kind of, recorded everything. This is ML Flow. The product that does this inside Databricks is called ML Flow. And it records, when you just run the experiment, we record everything for you in here. And this is what you would do, like generates all different kinds of model. You can actually look at the model. So Databricks says this is the best model, logistic regression. But if you go back here, you'll see maybe you are not so much, like the, this model. You think, actually, I need a model that is based not on logistic regression. Maybe I should choose a model that is based on something, and maybe decision trees, right? I think maybe I like decision trees. I know how it works, so I'm more comfortable working with decision tree. So you go here and you click on this one, and you'll see the model itself, right? And you can see the source notebook in here, and this is the notebook. Again, you can see the experiments, what we've done, but this time we used a decision tree model. So you got the best model, which is logistic regression model. You got preferred, let's say not best, preferred model, which is decision trees. It's up to you. Databricks will give it all the models that has been generated for you. So you would select the one that you would like, and the one that you think is now best for your data model. And once you have done this, so you've seen everything, you've trained your machine learning model. I think from as far as automatic machine learning is concerned, we've done the configuration, the first step, we've done the training in the first step, and now let's do the evaluation, and this will be pretty much the next lesson. So until then, let's see you in the next lesson.